In this lesson, we're going to focus on linear programming. I'm going to talk about how to solve it analytically first, and then we can work on some word problems. Now, there's two types of equations that you need to be familiar with. The first one is known as the constraint, and the second is the objective function. The objective function contains three variables, typically, or more, and the constraint usually contains two variables. So for example, let's say if we have two variables x and y. X plus y, let's say it's less than 20, that's a constraint. Another one, 3x plus 4y, is less than 72. The objective, we're going to say, is z. We want to maximize z. Z is 4x plus 5y. In this example, the objective has three variables, x, y, and z, and the constraints have two variables, x and y. And our goal is to maximize or minimize the objective function. In this problem, we're going to maximize z. Now, since we have three variables, we'll need three equations. Once you have your two constraints and the objective function, what you want to do is you want to plot these two inequalities. Let's begin by making a graph. And we only need to worry about quadrant 1, and that is this quadrant. Now the best way to plot it is to identify the x and y intercepts. So let's start with this one. To get the x-intercept, replace y with 0. So we can see x is 20. And to get the y-intercept, replace x with 0. So y is also 20. And then let's connect these two with a straight line. And that line wasn't straight. There we go. Now let's do the same thing for the next inequality. So let's find the x-intercept. So let's replace y with 0. So we have 3x is less than or equal to 72. And if we divide by 3, the maximum value of x is 24. Now let's calculate the y-intercept. So let's replace x with 0. So 4y is less than or equal to 72. And then let's divide by 4. 72 divided by 4 is 18. Now, let's say if we shaded this region, that's for the first inequality, and then this is for the second inequality, and then we shade that region. The region where both lines, or where we have both colors, is this region that I'm going to highlight in green. And it's always going to be like that. So we only need to shade just this region. Now once you plot the graph, identify the corner points. At one of these corner points, we're going to get a maximum. Now we really don't need this corner point because we're not looking for the minimum of the function. If we plug in 0 and 0, z will be 0. And we want to maximize z, so let's ignore that corner point. Now what I like to do at this point is make a table. A table with x, y, and z. So this first point here, the x-intercept, x is 20 and y is 0. And for this second point, the y-intercept, x is 0, y is 18. Now we need to find this point, and that's where the two inequalities intersect. So what we need to do is we need to solve this using systems of equations. We could use the substitution method or the elimination method. And I'm going to use the elimination method. So I'm going to multiply the first equation by -4. Actually, I'm going to use -3 to get rid of the x values. So it's going to be -3x minus 3y is less than or equal to -60. And then I'm going to rewrite the second equation right below it. So 3x will cancel, and -3y plus 4y, that's y, and that's less than or equal to -60 plus 72, which is 12. So y is 12. At least that's the maximum value of y at that point. Now we need to calculate x. So I'm going to use the very first equation, or the first inequality, before we multiply it by 3. So let's replace y with 12. 20 minus 12 is 8. So x is at most 8 at that point. Now we don't need the graph anymore now that we have our points of interest. So we need to calculate z and determine which of these 3 points will give us the maximum z value. So let's start with the first one, 20, 0. So z is going to be 4 times 20 plus 5 times 0. 4 times 20 is 80. Now for the second one, x is 0 and y is 18. So what's 5 times 18? 5 times 10 is 50. 5 times 8 is 40. 50 and 40 adds up to 90. And then for the last one, it's going to be 4 times 8 plus 5 times 12. 4 times 8 is 32. 5 times 12 is 60. So this adds up to 92. So notice that this is the maximum z value. It occurs when x is 8 and y is 12. So this is the process that you need to follow in order to solve a linear programming problem. For any problems past this point, all you need to do is be able to write the objective function and the 2 constraints. If you can do this, then you need to simply follow these steps that you've just seen, and you can find the maximum profit or maximum whatever it is you're looking for. Now let's work on a word problem. A company receives in sales $20 per book and $18 per calculator. The costs per unit to manufacture each book and calculator are $5 and $4 respectively. The monthly 30-day cost must not exceed $27,000 per month. If the manufacturing equipment used by the company takes 5 minutes to produce a book and 15 minutes to produce a calculator, how many books and calculators should the company make to maximize profit? And also, determine the maximum profit the company earns in the 30-day period. So if you want to try this problem, feel free to pause the video and work on it. Now what I'm going to do is make a table so I can organize all of the information that's presented in this problem. So first, we need to talk about the sales. The next thing is the cost, and also the time it takes to manufacture the items. And there's 2 items of interest: the books and the calculators. I'm going to use B for books, C for calculators. So the company receives in sales $20 per book and $18 per calculator. Now the cost to manufacture one book is just on average $5 and $4 to manufacture a single calculator. Now to make a book, it takes 5 minutes on average and 15 minutes to produce a calculator. And our goal is to maximize the profit, or basically maximize the sales in this case. The profit is really going to be the difference between the sales and the cost. So let's change this and say we're going to maximize the sales. If we maximize the sales, the profit will be at a maximum because the cost is fixed. So our goal is to maximize the sales in this case. The cost cannot exceed $27,000 per month. Now, what we need to do is write two constraints and one objective function. So let's start with the objective function. We're trying to maximize the profit, and therefore we need to maximize the sales produced by this company. So the company receives $20 per book, and we're going to say B represents the number of books that the company produces. So the sales that come from the books is going to be 20 times the number of books. And the sales coming from the calculators is going to be 18C, or $18 per calculator times the number of calculators produced by the company. And that's going to equal S, the total number of sales. Now we have three variables in this equation, and this is the objective function. We need to maximize S. Now let's focus on the constraints, and let's start with the costs. The cost cannot exceed $27,000 per month, and the cost to make a book is $5 per book. So it's going to be 5B, and then the cost to make a calculator, that's $4 per calculator, so 4C, and it has to be less than or equal to $27,000. So that's the first constraint equation that we have. Now we need to write the second constraint equation, and it has to do with time. So we have the time it takes to manufacture these items per minute. And the time limitation is per month because the cost was based per month. So how many minutes are in a month, or in an average of a 30-day period? So let's start with 30 days. Let's convert it to minutes. In one day, there's 24 hours. And in 1 hour, there's 60 minutes. So when converting, you want to set it up in such a way that the unit days cancel and the unit hours cancel. So it's going to be 30 times 24 times 60. And so that's 43,200 minutes. That's the time constraint. So it takes 5 minutes to make a book. So we're going to write that as 5B. And it takes 15 minutes to make a calculator. So 15C. And that has to be less than or equal to 43,200 minutes. So now that we have these three equations, we don't need this data table anymore. So let's focus on making a graph. And we only need the information in quadrant 1. So I'm going to put B along the x-axis, so you can make BX, and C along the y-axis. So let's plot the two inequalities. So let's start with the first one. 5B plus 4C is less than or equal to 27,000. And let's find the intercepts. So let's replace C with 0. If we do so, this will disappear. And so 5B is less than or equal to 27,000. And so B is going to be 27,000 divided by 5. And so that's going to be 5,400. Now let's replace B with 0 and calculate the value of C. So C is going to be less than or equal to 27,000 divided by 4. And so that's going to be 6,850. I wrote that wrong. Let me do that again. 6,750. Now let's move on to the second equation. So we can draw a straight line between those 2 points. Now let's replace C with 0 and let's calculate B. So this is going to disappear. So B is going to be 43,200 divided by 5. And so that's going to be 8,640. And then now let's replace B with 0. Now let's calculate C. So C is going to be 43,200 divided by 15. And so that's 2,880. Now the solution is going to be in this region. It's always going to be like that. And here we have the 4 corner points. But we're trying to maximize the cell, so we don't need this corner point. Now, there's only one more corner point we need to get, and that is the intersection of the 2 lines. So we need to solve this system. Now, notice that both of these are 5b. So the best thing we could do is subtract. I'm going to multiply the second equation by -1. So it's going to be negative 5b minus 15c equals negative 43,200. I'm not going to worry about the inequalities for now, but they're still there. So let's add these 2 equations. These will cancel. Negative 15 plus 4 is negative 11. And then negative 43,200 plus 27,000, that's negative 16,200. And then we need to divide both sides by negative 11. So C at this point, which I'm going to write here, is 1,472.72. Now, C represents the number of calculators, so I need to use a whole number. So I'm going to round it up to 1473. Now let's calculate the number of books. So I'm going to use the first equation. And let's replace C with 1473. So 27,000 minus 4 times 1473. So that's going to be 21,108. And then let's divide this by 5. So B has to be less than or equal to 4221.6. So we can't round up because it will exceed the inequality. So we need to round down. So I'm going to say B is 4,221 because we need to use whole numbers. So now that we have all of the points of interest, let's make a table. We don't need the constraint equations anymore. So we're going to have B, C, and the sales. So the maximum number of books that we can have represents this x-intercept, which is 5,400 books with 0 calculators. And then this intercept tells us that we have no books but 2,880 calculators. And then finally, the point of intersection. That was what I was trying to say. We can see that B is 4,221 and C is 1473. So now we don't need this graph anymore. So now let's find out which of these values will produce the maximum sales. So let's start with the first one. It's going to be 20 times B and then plus 18 times 0. So 20 times 5,400. That's $108,000 per month. Now, let's focus on the second point. That's when B is 0, but C is 2,880. So that's going to be $51,840 in monthly sales. And for the last one, B is 4,221 and C is 1473. So 20 times 4221, that's 84,420. And then 18 times 1473, that's 26,514. So if we add those two numbers together, the total sales will be $110,934. So clearly, this represents the maximum sales. And to determine the number of books and calculators the company should make to maximize the profit, it's 4,221 books and 1,473 calculators in a 30-day period. Now the profit, technically, is going to be the difference between the sales and the costs. So the sales is $110,934 per month, and the cost is limited to $27,000 per month. So the profit for that month is $83,934 per month. So that's the answer for the second part of the problem. Now let's work on this problem. A self-employed carpenter earns $90 for the sale of a table and $180 for the sale of a rocking chair. It takes 2 hours for him to make a table and 5 hours to manufacture a rocking chair. He is limited to working 40 hours per week. The average manufacturing cost is $15 per table and $40 to $5 per rocking chair. He wishes to keep his manufacturing costs at $315 per week. How many tables and rocking chairs should he make to maximize his weekly sales? And also, determine the maximum sales and profit he can make per week. Feel free to give this problem a shot if you want to. So let's make a table. Let's organize the information that we have. So we have information for sales, for time, the time to manufacture the items, and also the cost of manufacturing the items. And let's use T for tables and R for rocking chairs. So the sale for each table is $90. And the sale for a rocking chair is $180. It takes him 2 hours to make a table and 5 hours to make a rocking chair. And the cost per table is $15, and the cost per rocking chair, or to make a rocking chair, is $45. So with this information, we need to write 3 equations, 1 for the objective function and 2 for the constraints. Let's start with the objective function. So what is the goal here? What is the carpenter trying to do? Well, he wants to maximize his weekly sales. So The sales function is the objective function. Let's use S for sales. Now he receives $90 in sales for the sale of each table and $180 for the sale of a rocking chair. So that's the objective function. Now, we need to write two constraints using inequalities. So what are the constraints that we can write? Well, the first limitation is due to time. He can only work 40 hours a week. And he's using 2 hours to make a table and 5 hours to make a rocking chair. So 2t plus 5r has to be less than or equal to 40. The second constraint has to do with costs. Now he chooses to keep his manufacturing costs at $315 per week. Now, if its cost is less than $315 per week, I'm sure he's not going to mind about that. So we're going to use an inequality. Now the cost to make a table is 15. So we're going to write 15t, and then it's $45 to make a rocking chair. And we want that to be at most $315 per week. So now we have the two constraints and the objective function. So we don't need this table anymore. Now what we need to do is make a graph using the first quadrant. So let's put t on the x-axis and r on the y-axis. Now let's start with this equation. When t is 0, what is r? So if we have 2 times 0 plus 5r is less than or equal to 40. So that disappears. And if we divide by 5, 40 divided by 5 is 8. So the the y-intercept is going to be 8. Now, let's calculate the x-intercept. So if r is 0, this disappears, and 2t is going to be less than or equal to 40. So it's going to be 40 divided by 2, which is 20. So let's put this here. Now let's move on to this equation. Let's find the x-intercept. So if r is 0, we're going to have 15t is less than or equal to 315. So t is going to be 315 divided by 15, which is 21. Now let's make a line between these 2 points. Now the next point is going to be at 21. And then if t is 0, 45r will be less than or equal to 315. So 315 divided by 45 is 7. And so this is going to be the point of intersection. So we have 3 points of interest. And this is where the solution is going to be located in, somewhere in that region. Now we need to find this point of intersection. So let's solve this system of inequalities that we have. So I'm just going to use an equal sign to keep things simple. Now let's multiply the first equation by -9 so that r will cancel. 2t times -9 is -18t. And 5r times -9, that's going to be -45r. And 40 times -9, that's going to be -360. Now let's multiply, let's leave that the way it is. Because at this point, we could cancel r if we just simply add the two equations. So -45 plus 45 is 0. -18t plus 15t, that's 3t. And -360 plus 315 is -45. Now, if we divide by 3, this is supposed to be -3t, by the way. So if we divide by -3, we can see that t is 15. Now, let's calculate r. And let's use the original equation to do so. So 2 times 15 plus 5r is less than or equal to 40. 2 times 15 is 30. And if we subtract both sides by 30, 40 minus 30 is 10. So 5r is less than or equal to 10. And then if we divide by 5, 10 divided by 5 is 2. So the most that R can be at that point is 2. So now let's get rid of this. And let's make another table between the number of tables that's being produced, the number of rocking chairs, and then the sales that are generated as a result. So the first point of interest is this point. So at that point, T is 0, but R is 7. And then the second point of interest is when T is 20, but R is 0. And then at the point of intersection, we can see that T is 15 and R is 2. So now that we have that, let's determine the sales for each of those point of interest. So the first one, 90 times 0 plus 180 times 7, if we plug it into this formula, the objective function. So 180 times 7, that's going to be 1260 in weekly sales. Now for the next point, it's going to be 90 times 20 plus 180 times 0. And 90 times 20, that's 1800. And then for the last one, it's going to be 90 times 15 plus 180 times 2. And that comes out to be 1710. Now, let's focus on answering the question. So, how many tables and rocking chairs should he make to maximize his weekly sales? His weekly sales are maximized if he focuses all of his energy in making tables. So in a 40-hour work week, he can at most make 20 tables. And that's what he should do if he wants to maximize his sales. Now, to determine the maximum sales and profit he can make per week, it's simply this number. It's 1800 per week. That's the maximum sales. But the maximum profit is going to be the difference between his revenue or his sales, which is 1800 per week, minus his fixed cost of 315 per week. So his maximum weekly profit is 1485, but his maximum weekly sales is 1800 per week.